Greetings, everyone. Today we're going to re-look at factoring polynomials, specifically polynomials with a higher degree. One thing that'll be very helpful as we go through this is having your factoring foldable. One thing to consider too with this factoring foldable is keeping it into next year. If you're going into pre-calculus, it's going to be assumed that you know how to factor immediately. So, to help with that, hang on to this foldable, keep using it. We're going to spend more time on this. We have to get factoring down and make sure that we can factor smoothly and efficiently so that we can move on to higher topics. So remember that factoring means we're breaking apart into little things that are being multiplied. So I might start with polynomial, but end up with 3 factors that I could multiply to check my work. So it's the opposite of multiplying or undoing multiplying. So strategy is the same, but the answers are going to look a little bit different now that we're dealing with the higher order polynomials. So for example, if I have an exponent of 6, how does that look when I factor it? So first we need to recall greatest common factoring. Always try to take out the greatest common factor first. Not only does it make the numbers smaller and easier to work with, but it's also necessary for breaking it apart into the smallest pieces possible. So in this particular example, I have 25 and 50, so I know I can divide out a 25, and the most x values I can take out is 2, so I have x squared. If I divide that out, I have a 2x squared left over, minus anything divided by itself is 1. I still need to account for that value there. So if I was to solve this one, much easier to solve. I got 2 pieces, set them equal to 0. In this case, I'm just going to concentrate on the factoring piece. All right, let's also review group factoring. If it's already in standard form, we typically group the first 2 and the last 2. We then look for a GCF that I can divide out of each set of parentheses. So in this case, I can divide out a 6x squared. That leaves me with a 5x minus a 3. That means the goal of my second set of parentheses is also a 5x minus 3. So keep that in mind. If I want to minus, it means I'm going to have to take out a negative value. I can take out a 5, which leaves me with a 5x minus 3. So my goal, if I now take out that common factor of 5x minus 3, then I'm left with a 6x squared minus 5. Okay, so technically you're doing the GCF twice. It just happens that your greatest common factor is a binomial that I've identified in blue. Then we always double check, do I have any difference of squares, any other GCFs or simplifying I need to take care of? And I don't. So that would be my answer to that question. Trinomials. So in the past, trinomials, we've stuck to sort of that basic quadratic with an x squared, an x value, sometimes a constant. But now we're going to take a look at what if I increase both exponents. So I have a 4 and a 2. What if I triple it and I have a 6 and a 3? How do I deal with that? Well, it should look, the process is the same. It should look very similar, just with higher exponents in the end. So let's just recall from previous work how to factor a basic quadratic. So in this case, we're going to use guess and check. So factors of 2 are 2 and 1, so that's my only option for my first terms. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. So I actually have some options here. So I don't think 1 and 12 are going to get me to 5. So I'm just going to jump right in the middle, and I'm going to say 2 and 6, let's say. So if I try that out, 2 and 6, outer would give me 4, inner 6, that's never going to get me to a 5. What if I swap them? A 12 and a 2, never going to get me to 5. Okay. So now let's try 3 and 4. 3, 4. An 8 and a 3, hey, that could get me to 5. So in order to get me to 5, I need a positive 8 and a negative 3. Oh, wait, I want a negative 5. So see how I'm going through that thought process in my head of guess and check. If you need to physically write it out each time, then try that. Okay. But I need a negative 8 and a positive 3 to get me to negative 5. So in my mind, I'm just thinking outer, inner, back and forth. And again, double check before you leave your answer and make sure it works. First, 2x squared, outer negative 8, inner positive 3, last negative 12. So I'm confident in this factored polynomial. All right, but let's take a look if I have a higher degree. First thing you should always check for every problem, is there a GCF? And in this case, I can definitely divide out a 4, and the most x's I can take out would be 2x squared. So that would leave me with x to the 4th, because when I divide out, do I subtract or do I divide? In this case, you subtract. So be very careful with that. Remember, x to the 6th divided by x squared leaves me with x to the 4th. We subtract those exponents. I have a minus sign of 5, x to the 4th divided by x squared is x squared. Last would be, what do we got? 6 with no x value. All right, so I have my GCF up front. I'm going to keep bringing that down. But now I have a trinomial with a leading coefficient of 1. So typically we just do xx. But because I have x to the 4th, I need to do x squared. My factors of 6 are 1 and 6, 2 and 3. And I have to watch my signs. They add to get negative, but multiply to be positive, which means they both have to be negative. So if they're both negative, which one can get me to a negative 5? A 2 and a 3. If you weren't sure, just do a little bit of guess and check. I'm going to double check here. X to the 4th, negative 3x squared, negative 2x squared. That gets me to negative 5x squared, and positive 6. So I'm confident in that answer. Then always double check. Do I have difference of squares? I have a square and I have difference, but 2 is not a perfect square. I have a squared and a difference, but 3 is not a perfect square. So because I can't go any further, that would be my final answer. Speaking of difference of squares, let's still take a peek here at difference of squares. Always check first if there's a GCF, okay? And in this case, there isn't a convenient GCF. But if I take a look as well, that's okay because both of these are perfect squares. So what's the difference from before? The difference is now my square root of x to the 4th is x squared. So I have a higher degree. Okay? Remember, one's positive, one's negative every time you do difference of squares. But take a look. Difference of squares led me to more difference of squares. Now this one is a positive, so it can't reduce. But this one can break down again. 4x squared, if I square root that. 9, if I square root that. Positive, negative. So I end up with 3 pieces broken apart. I could remultiply them out if I wanted to make sure I was correct. So again, quick review. Always look for the GCF first. Like that should be the first thing you do on every single problem. Next, if you have 4 terms, I need to see grouping. If there's 3 terms, you need to see trinomial factoring, guess and check. 4, if you have 2 terms with a difference and squares, you do difference of squares. So looking ahead, make sure as always you check Google Classroom, see if there's anything else to go along with this video. Check PowerSchool, make sure you're all caught up, and keep practicing factoring. Okay, there's so many options online. If you want any resources, websites, practicing, you just let me know because factoring needs to become second nature. So keep working on it. Let me know if you have any questions.